Hey guys, welcome to my YouTube channel. But before we proceed, kindly subscribe to my YouTube channel and also like my videos and share my videos. I would like also to hear your views and what you think about my videos, so please don't forget to comment. In this video, I'm going to teach you how to solve question 7G up to question 7G from Mathematics to Sheet 4. And Mathematics to Sheet 4, we know that it's on a trigonometry. So question 7A up to question 7G, they are on identities, trigonometric identities. But guys, those who have been following me very well, I made a video, I think 2 weeks ago, where I solved question 7A up to question 7C. So today, I'm just going to proceed from question 7D up to question 7G. Then I'm going to make another video soon where I'm going to solve question 8. Then we are done with sheet 4, and then I'll go to sheet 5, which is on calculus. So please don't forget to hit the notification button so that every time I post a video, you get notified. So just stay tuned. So question 7D, we've been given to prove this identity, which is sine x divided by 1 plus cos x plus 1 plus cos x divided by sine x. And this is equal to 2 cosecant x. So my best advice that I can give you guys when you're dealing with these kind of questions, you need to identify the most complicated part. So you're going to use the most complicated part to drive the least complicated part. So when you look at these two sides, what we have on the left hand side and what we have on the right hand side, you're going to see that this side is more complicated than that. So we can use this side to get that, okay? But if you try to use the other side, for example, let's say that you try to use this side to show it's equal to that, it's going to be very challenging. So better use the complicated part to drive the least complicated part. That's my best advice. And I also advise you to know the inverse trigonometric identities, the sum difference trigonometric identities, and also you need to know the Pythagoras identities for you to solve this kind of question. All right, so let us see how we can solve this question. So the first thing that we are going to do, we are going to find the common denominator of this expression that we have on the left hand side. So what's the common denominator? We're just going to multiply 1 plus cos x times sine x, which is sine x multiplied by 1 plus cos x. Okay, and I would advise you don't you shouldn't distribute, just leave it like that. Then we're going to say 1 plus sine x, open brackets, 1 plus cos x divided by this. So we find that is equal to sine x. Then sine x times this sine x on top is the same as, so it's the same as sine squared x. What else are you going to do? We're going to get this and divide it into that. Okay, so 1 plus cos x divided by sine x, it is equal to what? So this sine and that sine will cancel. So just going to say this is equal to, okay, so this is equal to 1 plus cos x. So we've got this 1 plus cos x on top there. So 1 plus cos x, and then sine x, I mean this part, denominator divided by sine x is equal to this. It's okay, it's equal to this, okay? So we say times 1 plus cos x. Okay, so when you do this, we're just going now to expand. So what are you going to expand? You're not going to expand the denominator, no. We're going to expand the numerator. So let us see how we are going to do that. So we add the sine squared x plus 1 plus cos x times 1 plus cos x, then the whole thing divided by sine x 1 plus cos x. So we are going to distribute the numerator. So this implies that this is sine x or sine squared x 1 times, so we're going to distribute 1 times 1 and then also 1 times cos x. So 1 times 1, that is 1. 1 times cos x, that is cos x. After that, we are also going to distribute cos x. So cos x times 1, that is cos x. Cos x times cos x, that is cos squared x. Then divided by the denominator. So you have to know that the denominator is not changing at all. So you don't have to expand that. If you expand it, you're going to make your life difficult. Okay. So here now, we're just going to add similar terms or like terms, we had them. And then you need, that's why I said earlier that you need to be familiar with several identities that are in trigonometry. So I mentioned something like Pythagoras identity. So Pythagoras identity states that cos squared x plus sine squared x is equal to 1. So this is Pythagoras identity. You need to be familiar with these identities. They're very important. So let's come back to our question now, or to our calculations. So we know that we've got sine squared x there, and also cos squared x there. So we can add these two terms, because we know that cos squared x plus sine squared x is equal to 1. So it's a sine squared x plus cos squared x is equal to 1. All right. So when we had this term and this term, they're going to give us 1. From this identity, if you look at this identity, okay, so we know that sine squared x plus cos squared x is equal to 1. So we got 1 there, and then that 1 plus this 1 there, going to give us 2. So let us try to rewrite that. Then this part we also had, which is equal to 2 cos x. So let us try to rewrite that. We've got 1 plus 1, which is 2, and then plus 2 cos x. That's our numerator. So we've got 2 plus 2 cos x divided by what? So divided by the numerator. So our numerator was sine x. Oh, sorry, it's the denominator. I'm sorry about that. So our denominator is 1 plus cos x times sine x. Okay. So now we're just going to factorize the numerator. So we're going to factorize it. We know that 2 is common. So 2 will be taken outside or be factored out. Then we are going to remain with 1 and cos x. This divided by the denominator, which is sine x 1 plus cos x. Okay, so now we see that something can be cancelled out there. So this 1 plus cos x and 1 plus cos x can go. And we've remained with, so this implies that we've got 2 on top as our numerator and then sine x as our denominator. So this can be also written as 2 1 over sine x. It's the same thing, because when you distribute 2, it's still going to give you 2 over sine x. Okay. Then there is another identity that you need to be familiar with, and this is under inverse trigonometric identities. So this identity is sine x, or another way, let me say cosecant x. Cosecant x is equal to 1 over sine x. So you need to know this. Cosecant x is 1 over sine x, and sine x is equal to 1 over cosecant x. So this is a very important trigonometric identity also. You need to add it to your notes. So cosecant x is equal to 1 over sine x, and sine x is equal to 1 over cosecant x. So what are we going to do? So we are going to replace 1 over sine x with cosecant x. So this is equal to 2 cosecant x. So this is our final answer. This is what we had on the right hand side. So we've proved that what we had on the left hand side is equal to what we have on the right hand side. So this is all for question 7D. Let us go to question 7E. Question 7E, we've been told to prove this identity. So prove that root of 3 times sine 2 theta minus cos 2 theta is equal to 2 sine, open brackets, 2 theta, then minus pi over 6. So this is the identity that we have. How can we do this? Because both sides, they look complicated, right? So how can you know that I have to start with this side? So the best way to do this is that you need to look at the identities that we have. So for example, like we've got sum and difference trigonometric identities. So you can spot something here. So this side, you can know that this is a difference of what? Difference, sine difference trigonometric identity. Okay, this is where it is coming from. Okay, so when you just spot that, then you can know that, okay, this side, the right hand side is going to be easier for me to prove the left hand side. All right. Oh, the other way that you can do that, start with the right hand side, try to drive the left hand side. If it's not working, start the other way. All right. So you can do vice versa if it's not working. Trial and error. So this one, we're going to start with this side to prove what we have on the left hand side. So there is another trigonometric identity that you need to be familiar with. So this is under sum and difference trigonometric identities. So this identity states that if you got sine a plus b, okay, so if you've got sine a plus b, so this is equal to sine a cos b. So if there is plus there, the sign will be maintained. It's going to be plus cos a. So the functions have switched, cos a, then sine b. Okay, so this is another trigonometric identity. You need to add these to your notes. Okay, and then if you've got, let us say, sine a minus b, this is equal to sine a cos b, and then since there's a negative sign there, the sign will be maintained. So it's going to be minus cos a multiplied by sine b. So this is another trigonometric identity. So now, which one do you think we are going to use? Between this one, the first trigonometric identity, and the second. So how can you know? You have to come here. Okay, so you need to know to see that there is a negative sign. So which means we are going to use this, which has got a negative sign, because it's a difference. Okay, so they are trying to find the difference. So let us see how we can do that. What did we have, or what do we have on the right hand side? So on the right hand side, we've got 2 sine 2 theta minus root of, sorry, pi over 6. Okay, yeah. So now we are going to say our a is 2 theta, and then this is b. All right, so the whole thing here, it is our b. Then we say, just try to write the formula again. So sine A minus B is equal to sine A cos B minus cos B sine A. So that's the formula. So we're going to say that 2, let us try to factor out these 2. So if 2 is factored out, we are going to remain with sine in the brackets. So sine, open brackets, 2 theta minus pi over 6. So you have to change this angle, which is in radians measure, to angles in degrees measures, because it can be very complicated or sometimes very confusing to work with angles which are in radians. So you can convert that. So pi, we know that pi is 180. So 180 divided by 6, which is equal to 30 degrees. So now let us try to use this formula. Sine, so sine A, what is our A? Our A is 2 theta. So we say sine 2 theta times cos B. What is our B? Our B is 30 degrees. Then minus cos B. What is our cos B? So now, sorry, I made a mistake there. I made a mistake in the formula. I'm sorry about that. It needs to be cos A, then sine B. Please make a correction there. I made a mistake. I'm sorry about that. So we're going to say minus cos A. So what is our cos A? So cos A is cos 2 theta. Our A is 2 theta. Then times sine B. So what is our sine B? Our sine B is the same as sine 30 degrees because our B is 30 degrees. So now this implies that 2 theta sine 2 theta times cos 30 degrees. So what is cos 30 degrees? When you go on the unit circle there, what is cos 30 degrees? So cos 30 degrees is the same as root of 3 over 2. So on the unit circle, cos 30 degrees is equal to root of 3 over 2. Then minus cos 2 theta. What about sine 30 degrees? So sine 30 degrees on the unit circle is equal to half. So you need to know the unit circle, because in the exam, you're not going to have a calculator, or they won't even provide the same circle. So you need to know it. So that's what we have. So we are going to factor something out. What are we going to factor out? So we know that root of 3 over 2 is the same as root of 3 times half. So we know that we have got half there, and there's half. So we can factor out half. So this is equal to, so this is equal to half, and then multiplied by sine 2 theta, okay? Sorry, and then in brackets we've got root of 3, okay? Minus cos 2 theta, cos 2 theta, okay? In brackets like that. So what we've done is that we've factorized, or we have factored out half. So half has been taken outside. There we remained with root of 3, and there's only 1. So 1 times cos 2 theta is same as cos 2 theta. So what else can we do here? We can divide by that. 2 divided by half, just 1. So we can say this is equal to root of 3 sine 2 theta minus cos 2 theta. Okay, so we are done. This is what we had on the left-hand side. We've proved that what we had on the right-hand side is equal to what we had on the left-hand side. So if you check it up, this is what we had on the left-hand side. Let us now go to question F. Question 7F. So question 7F. What is the question? So the question that we have is cos theta. So cos theta plus sine theta is equal to the root of 3. Sorry, that is root of 2. Okay, root of 2 sine. So root of 2 sine theta plus pi over 4. So this is our question 7F. We've been told to prove this identity. How are you going to do it? So like I said earlier, make sure that you identify the most complicated part. So as for me, I've seen that the most complicated part, it is the right-hand side part. So I'm going to the right-hand side part to derive the left-hand side part. So when you see there is addition. So addition, and then there is sign there. So we're going to use this identity. Sin A plus B is equal to sin A cos B, then plus cos A sin B. So we are going to use this identity. So we are going to use this part to drive this part. So let us see how we can do it. So what is our A? So let us try to identify our A. So this is our A, and then this angle is our B. So like I said, you need to make sure that you convert the angles to degrees. It's going to be easier for you to work it out than when the angles are in radians. It's very confusing. So I'm going to factor out 2. Then sine. So when you follow this formula, what is our sine A is same as sine theta. Sine theta. And then multiplied by cos B. So what is cos B? What is pi over 4? So we know that pi is 180 divided by 4. 180 divided by 2 is 90. 90 divided by 2, that is 45. So it's 45. So pi over 4 is the same as 45. So our B is 45 degrees. So we can say cos B is the same as cos 45 degrees. And then plus. What is our cos A? So cos A, same as cos theta. Multiplied by, what is our sine B? So sine B is the same as sine 45 degrees. Okay, so this is root of 2 sine theta. What is cos 45 degrees? So when you go on the unit circle, cos 45 degrees is equal to root of 2 over 2. So we can say this is same as root of 2 over 2 times sine theta plus, what is sine 45? Okay, so cos 45, we know like it's root of 2 over 2. This one. So what about sine 45? So sine 45 is the same. So cos 45 is root of 2 over 2. Sine 45 is root of 2 over 2. You have to know that. So this is root of 2 over 2 times cos theta. Okay, so we know that the coefficients, they're equivalent. So we can factor them out. So this is the same as. So this is the same as 2, then root of 2 over 2 sine theta plus, so this is root of 2, okay, plus cos theta. Okay, so now we can say root of 2 times this root of 2. So it's the same as root of 4. So root of 4 is equal to 2. So this is 2 divided by this 2. Then multiplied by sine theta plus cos theta. So this we can divide it, it's 1. So our final solution is equal to sine theta plus cos theta. So this is the answer. This is what we had on the left hand side. So we had cos theta plus sine theta, which is the same as sine theta plus cos theta. So this is all for question 7F.